Constructing a heavy industrial process plant requires mastering both macro-scale architecture and microscopic chemistry. That exact integration is the core mandate at Fossil Wood Engineering. High-performance industrial grease is a highly precise water and oil emulsion. It is a delicate matrix that heavy industry and automotive machinery rely on to prevent catastrophic friction in extreme environments. This graphic breaks down the emulsion. The foundation is a refined base oil. Next, reacting fatty acids with alkalis creates a structural soap matrix. Finally, performance additives are folded in, allowing the industrial grease to tolerate extreme pressures and thermal loads. Scaling these formulations beyond the laboratory requires guaranteeing structural stability and precise drop points across thousands of kilograms. Every batch must match the target specifications without a single microvariance. Without absolute thermodynamic precision and mechanical shear control during processing, the emulsion will separate, the oil will bleed out, and the machinery relying on it will tear itself apart under stress. Meeting those tolerances globally requires a massive operational footprint. This map shows Fossil Wood's infrastructure, anchored by a state-of-the-art manufacturing headquarters in Chennai, India, with specialized hubs in Dubai and Magdeburg, Germany, directly servicing the Middle East and Europe. Looking at their project data, over 8 years, they've executed more than 30 large-scale industrial facility deployments. These are governed by strict HSE compliance protocols, verified by simultaneous certifications in ISO 9001, 14001, and 45001 for quality and occupational safety. That safety framework translates directly to the field. Fossil Wood recently cleared 1 million consecutive work hours without a single lost time incident. This slide breaks down their operational architecture. Their core competencies stretch beyond grease, covering end-to-end capabilities across the wider process, oil and gas, and petrochemical sectors. For the facility owner, these metrics are entirely about risk mitigation. A pristine safety record and proven global execution mean fewer delays, continuous operation, and ultimately a heavily protected capital investment. This diagram maps the process flow for continuous grease manufacturing, from bulk storage to packaging. The cycle begins at step 1. Base oils and liquid fatty acids are drawn from flex tanks and pumped through precisely calibrated feed manifolds directly into the primary reaction zone. Historically, the major bottleneck in this process is saponification. Traditional atmospheric kettles require massive amounts of thermal energy and excessive holding times just to form the basic soap matrix. This matrix details the equipment deployment. Notice the first column. Fossil Wood replaces the atmospheric approach with specialized pressure kettles. These vessels are engineered to force the chemical reaction under extreme temperature and pressure conditions. Inside those vessels, a contra-rotary agitator works with rapid heating systems. This constant, heavy-duty mechanical folding maximizes the chemical yield and prevents lumps. By manipulating the thermodynamics and pressure, this engineering reduces total batch saponification time to just 3 to 4 hours. Returning to the process flow, we move to step 3. The concentrated soap is transferred into larger, universally sized finishing kettles, where the remaining base oils are blended in and the mixture is cooled at normal atmospheric pressure. Because these kettles are mounted on highly sensitive load cells, operators can hit their formulations with down-to-the-gram accuracy when introducing the final performance additives. Conquering the thermodynamics of saponification in these initial vessels is what dictates the rest of the facility's performance. It sets the baseline for both the plant's overall energy efficiency and its maximum daily production volume. But the chemical reaction is only half the battle. Post-saponification, the grease is extremely viscous, and the fluid dynamics require intense physical refinement. This is a stator-rotor milling machine. Cast steel components spin at high speeds, applying extreme mechanical shear forces to physically smooth the thick emulsion. Operators can dynamically adjust the microscopic gap between the stator and the rotor mid-cycle, dialing in the exact fineness and flow rate required for specific industrial standards. This intense mixing creates a secondary problem, entrapped air. Microscopic gas pockets folded into the grease cause oxidation, accelerate rancidity, and create volumetric errors when filling barrels. To neutralize that threat, the grease moves to step 4, the centrifugal vacuum deaeration chamber. Inside this enclosed steel chamber, the grease is spread thinly over a high-speed rotating disc. Centrifugal force pushes the material outward, while a vacuum pulls the entrapped air right out of the emulsion. Without this rigorous two-step sequence of intense shear milling and total vacuum deaeration, achieving a glossy, structurally sound, and market-ready industrial grease is simply physically impossible. This schematic highlights the custom three-dimensional layout engineering of the complete plant. Getting the physical piping and vessel locations right is crucial, but it's only the skeleton of the facility. This panel outlines advanced plant capabilities. Hardware is governed by a digital nervous system, relying on integrated SCADA interfaces. Variable frequency drives dynamically manage agitator speeds based on real-time batch thickness, optimizing power consumption second by second. Simultaneously, automated data loggers track product temperature and internal vessel pressure. This generates an immutable, exact digital record for every single batch that leaves the floor. SCADA integration creates an intelligent, repeatable manufacturing asset, where every process is governed by digital logic to protect profit margins. Transitioning to the business execution, constructing a plant of this scale presents massive logistical hurdles. Sourcing kettles, pumps, controls from disparate vendors introduces severe integration blind spots and timeline risks. This chart contrasts standard equipment sourcing with the fossil wood turnkey ecosystem. By centralizing the entire build, they operate with single source responsibility. This de-risked timeline begins with 3D concept engineering, moving to vendor procurement in Phase 2. In Phase 3, core equipment is built in their Chennai workshop, guaranteeing CE compliance before shipping. Finally, Phase 5 provides rigorous testing and utility synchronization directly on the client site. Executing these phases as a single, uninterrupted timeline strips out redundant labor overhead, drastically reduces on-site erection duration, and accelerates the client's overall time to market. When one firm owns the entire lifecycle, from the initial fluid dynamics modeling down to the final pipe weld, they eliminate the interface friction that stalls complex builds. That ownership is exactly how Fossil Wood maintains a 98% project delivery success rate. The final hurdle of any plant build isn't the physical construction, it's the transition from a dormant facility to live, profitable operation. Phase 6 provides the final operational link. Fossil Wood delivers a day-one guarantee, consisting of exact starting formulations and comprehensive technical training for the on-site staff. According to this breakdown, guaranteed quality assurance requires proper laboratory testing. Because of this, every plant is physically bundled with essential operational instruments like cone penetrometers and drop point testing apparatus. Fossil Wood Engineering Services and Contracting exists to deliver precision manufacturing solutions tailored to the most complex industrial challenges, executing flawlessly from initial concept to final commissioning. To initiate your consultation, scan the QR code on screen to access a virtual facility tour and connect with their engineering team. Alternatively, visit the Fossil Wood website or use the provided emails to speak directly with an execution specialist about your capacity requirements. Partnering with Fossil Wood ensures that high-stakes, complex chemical engineering is translated directly into an immediate, turnkey, and highly profitable reality.